Do you hate it when your video buffers? Don't you like to have a fast internet using the next generation 5G on your mobile phone? To achieve the benefits of 5G, FQAM is here. But what is FQAM? FQAM is FSK plus QAM. FSK, or frequency shift keying, is representing symbols, zeros and ones, by sine waves with different frequency for each symbol. It is used in wireless and telephone modems and also for caller ID. QAM, or quadrature amplitude modulation, is a method used to transfer information using a signal composed of two carrier waves shifted by 90 degrees. It is typically used for analog and digital TV broadcast and in radio communication systems such as Wi-Fi. FQAM is composed of one active frequency component carrying a QAM signal, where both frequency component and QAM signal are carrying information. FQAM is proposed to be used with the next generation of mobile communication, that is 5G. Here is a transmission-reception model for a signal using FQAM modulation. First, the input data bits gets interleaved and turbo-coded, a forward error correction method typically used in 3G and 4G to achieve a reliable transmission. Then it gets modulated the same way a QAM signal would get modulated, where the signal components are amplitude modulated, meaning multiplying each signal by the carrier, resulting in the waveform getting modified to convey the message. Next, the modulated signal is processed with an inverse fast Fourier transform, and to better immune the signal from noise, cyclic prefixes are added. Cyclic prefixes are added to prevent interference between two consecutive bit sequence or symbols. Now the signal is ready to be transmitted by the base station, ready to be received by the user. While the signal is on its way toward the user, noise and interference, usually from other base stations, affect the signal. Here the benefits of turbo codes and CP to detect and correct errors introduced in the signal appear. And now, for the receiver side, when the signal arrives to the user, a reverse procedure is done. The cyclic prefixes are removed and a fast Fourier transform is applied to reverse the effect of IFFT. Now the signal is ready to be decoded. The detector will treat the noise and the intercellular interference as a complex distribution. After decoding is complete, the signal interleaving the turbo coding are removed, resulting in the original transmission bits. Now let's take a look at these results shown in the frequency and quadrature amplitude modulation for 5G networks research paper that we used as the basis for most of the information stated in this video. When one base station is around, FQAM has an advantage where it has a higher SNR because the power is given to a single frequency component as opposed to QAM. With the same conditions for both the QAM and the FQAM modulated signals, we noticed the improved performance of FQAM notably when 3 base stations are around, as FQAM is less susceptible to interference. But when the number of base stations increased to 7, the performance advantage of FQAM isn't as noticeable due to the higher intercellular interference. All these advantages suggest that much more attention should be raised in considering FQAM as a promising technology in the 5G mobile networks. Well, that just about covers it. Thank you all for watching our video. I hope our information were valuable and useful to be used in your studies.